And I would use that measuring device to measure something. That's called direct measurement because I'm actually physically measuring things. Indirect measurement is where I do not actually get out a ruler and measure something. I use another object to figure out the size of another object. It's indirect measurement. So direct measuring is when I actually physically measure something. Indirect measurement is when I am using a measurement to find another measurement. I'm using something to find another. So we are still going to have proportions. So this indirect measurement uses proportions to find a missing measurement. So I am going to use proportions to equal fractions to equal ratios. And I'm going to use those two equal ratios to find a missing measurement, a missing value. So I will tell you this right now. It's going to be very helpful in the beginning. Draw a picture. This is going to be a big part of using indirect measurement. In the beginning, when we're first learning how to do this, the picture is what's going to help us. Drawing a picture is the big clue to solving these problems. So, for example, indirect measurement, these types of questions are actually pretty popular across math. They're used a lot as example problems because people kind of remember them. So here's an example. Are you ready? And yes, you need to write this down. It says, a tree casts a 10-foot shadow. Mrs. Long is 6 feet tall. I'm not. And casts a 4-foot shadow.
How tall is the tree?
How tall is the tree?
That's a good question. What do you want?
Okay. So, this is an indirect measurement problem because I have two things that I'm measuring. I have a tree and I have Mrs. Long. Now that tree, I know one of its measurements. But Mrs. Long, I know two of her measurements. I know how tall Mrs. Long is, and I know how long Mrs. Long's shadow is. The tree, I do not know how tall it is, but I know its shadow. And if I know two things that are the same, I know both of those shapes' shadows, and I know one of the shape's height, I can use a proportion to figure out the other one. So here's how we set it up. The key is draw a picture. It does not have to be beautiful. Here's my tree. And here's my Mrs. Long. So I know that my tree casts a 10-foot shadow. And I know that Mrs. Long is 6 feet tall. And I know Mrs. Long has a 4-foot shadow. I do not know how tall my tree is.
I know how tall it is. I know how tall it is.
But if I have this picture, I can use proportions to find the missing measurement. Here's how you set it up. You're going to make a proportion for the tree. That's item 1. And you're going to make a proportion for Mrs. Long. That's item 2. The tree is X over 10. This is tall and this is shadow. X over 10 equals 6 over 4 because this is tall and this is shadow. I have to make a proportion. I have to make a fraction for my tree, and I have to make a fraction for Mrs. Long. Those are the two things that I'm measuring. I'm comparing. I'm using indirect measurement of the tree and Mrs. Long to figure something out. So to do this, we cross multiply. X times 4 is 4x equals 10 times 6, which is 60. So how tall is the tree?
50.
How'd you get it?
I did 60 divided by 4.
15. Thank you for remembering your label. Indirect measurement. We're using the measurements of one item to measure something else. I'm going to give you some practice problems. Are you ready?
Sure.
Reagan. To figure out what your common ratio is? That would work too. Good. All right, here's another one. The scale on a map is 1 inch to 4 miles. What is the actual distance if it measures 2.4 inches on the map? Do I have to draw a picture for this one?
No.
I mean, you could draw a picture of a map and all that stuff.
But who wants to do that?
That sounds like a lot.
Hey, I know the answer.
All right, so but what are the two things that I'm comparing? What am I comparing to what? What are my two objects
Inches
of
to
measurement?
miles. Inches to miles.
Not inches to miles.
Miles to inches.
Nope. What am I comparing? What are my two objects?
The map.
The map,
And the scale.
not the scale.
Real life.
Real world. I've got my map, and I want to know actual real world distances. Those are what I'm using. Those are my two things that are being compared to each other. I'm using a ratio of inches to miles, right? I'm using a rate, I guess it would be a rate because they're different labels, a rate of inches to miles, but I'm comparing the map to the actual real world. What's my fraction, what's my proportion for the map? 1 inch is 4 miles equals, what do you know about the real world?
24,
2.4 inches. And I don't know how many miles, right? X. Since they're equal fractions, my inches and my miles, right, and comparing them, they're in the same proportional relationship. I can cross multiply. What's 1 times x?
1x.
Can I just put x?
I mean, yeah, you can.
Equals 4 times 2.4. 9.6 what?
Miles. Squared.
Not squared. So on my map, if it was 1 inch, made 4 miles, and on my map, those two cities are 2.4 inches away, in real life, they're 9.6 inches away.
I really hope you miles 6 inches away? You mean miles?
Yeah, miles, sorry. All right, let's do another one. Indirect measurements. Sometimes
What is she doing to you? She's drinking her water.
You can use measurements you already know to create for another set. If I say a mother elephant
Weighs like 500 pounds.
is 11 feet tall and casts a shadow that is, I'm going to change this to 10 feet because I don't like the number 11. That is 14 feet long. A mother elephant is 10 feet tall and casts a shadow that is 4 feet long. So the sun is close to the horizon, right?
Mm-hmm.
The elephant shadow is longer than it is tall. So the sun's not above them, making a short shadow. It's a long shadow. It's close to the horizon. Either early morning or late afternoon. Yes?
My mouse just ran, like, right there.
It's okay. You'll survive.
Scared me. A mouse? Oh, yeah, there's a mouse. I've never seen a mouse.
No, sit down. A baby elephant. A baby elephant has a shadow that is 8 feet long. How tall is it?
Oh, I know how tall it is.
The mama elephant is 10 feet tall and casts the shadow that is 14 feet long.
Wait, would the shadow go on